All right, so we're on to 5.7 now, and this is the word problem chapter or section. And for this section, we want to work through a few of these, start thinking about what a quadratic function represents, and look at the real world situations and see which one we need to do. So example 1, an old Pizza Inn menu from the 1960s lists the following prices for plain cheese pizza. A small, you can see all that. Now, letter A, assume that the price is a quadratic function of the diameter, okay? So we would normally have y equals ax squared plus bx plus c. In this situation, y is our price and x is our diameter. Because they say that the price is a function of the diameter. So the diameter is what determines the price. The diameter is the independent variable. The price is the dependent variable. Now write the particular equation expressing price in terms of diameter. Now we could use a P here and a D here. I'm not going to do that, but we could do that. So we want to get, so here's where we're starting from. Then we've got to look at our points that we have. What points do we have? Well, we want our points diameter, price. Our first point is 85 cents per for the 8-inch diameter. It's a cheap pizza. Then we have a 10-inch diameter for $1.15. Then we've got a 13-inch diameter for $1.75. So those are our 3 points. And when we substitute these 3 points in for our x's and y's, we're going to end up with 3 equations and 3 things we don't know. We won't know A, B, or C. So we're going to need 3 equations. We can make the 3 equations with these, and then we'll be able to solve. So now we have gone from looking in the real world, taking the information and making it into a math problem. We're in math world now. We've already translated all this information in math. We don't have to worry about the real world for right now. We can just be able to keep on going with math. We want to substitute in, and you know what I'm going to do here just to make life easy, is we're going to do this in cents as opposed to dollars and cents. That way we don't have to worry about that decimal point at all. So we're going to go ahead and substitute this in. We'll get 85 is 64a plus 8b plus c. That's our first equation. Of course, we're going to go ahead and we're just trying to find the exact equation for this price model. Then we're going to have 115 equals 100a plus 10b plus c. Then we're going to have 175 equals 169a plus 13b plus c. So those are my 3 equations. And we would need to solve this like we did in the previous section. But because this problem is so long, I'm going to assume that you understand how to solve these 3 equations and these 3 unknowns. And I'm just going to go ahead and go right with the answer here, that A is 1, B is -3, and C is 45. So there's our equation. And that completes what they wanted us to do for this. We have, when they say give us the particular equation, what they really want is to say y equals x squared minus 3x plus 45. We're taking these and putting them into our y equals ax squared plus bx plus c. So there's our particular equation. Now, they want us to, in letter B, if Pizza Inn made a 20-inch pizza, what do you predict the price would be? So they've given us a 20-inch pizza, which means a 20-inch diameter pizza. What would the price be? Well, I would say y equals 20 squared minus 3 times 20 plus 45. And that's how I figure out, they've given me the diameter, which means I can find the price. So 400 minus 60, which is what, 340, plus 45 is 385 is the price, I think. Let me check it. Yeah. So $3.85 would be the price. Of course, we're talking in cents here, so there you go. Now, in the next letter, letter D, the price intercept is the price where the diameter is 0. So what does the price intercept equal in this model, and why do you suppose that that is greater than 0? So the price intercept, when the diameter is 0, so really they're asking for the y-intercept, we're going to get 45. So the price of a 0 diameter pizza would be 45 cents. Of course, no one would ever pay that. But the idea here is that when you make pizza, for every pizza that you make, you're going to need to have a kitchen, you're going to need to have a refrigerator, you're going to have people working, and this price is going to represent some of that overhead from the store. That's really what we're talking about here. All right, so on to did I skip one? Oh, I did D. I should have done C. Let's go back to C. Suppose that the menu had listed a colossal pizza costing $6. Let's find the diameter. So they want a pizza that's $6. So 600 equals x squared minus 3x plus 45. Well, I have an equation. I have one variable. Awesome, I can solve it because I've got one equation and one thing I don't know. I don't know x. So in order to solve an equation, remember there are basically 3 steps to solve an equation. 1, set it equal to 0. 2, factor. 3, state your solutions. All right, so first let's set it equal to 0. So I'm going to get 0 equals x squared minus 3x. I'm going to bring this over, minus a 555. Yeah. All right, so that's pretty simple. Now I've got a quadratic that I can't factor. So what we want to do here is use, when you have we want to factor, I can't factor this in my head. So what I'm going to use is the quadratic equation, which will be the opposite of b, 3, plus or minus the square root b squared, which is 9, minus 4 times 1 times 555. 4 times a times c. And my a value here is 1, my c value is 555, and my b value, I'm sorry, negative 555, don't forget that. And my b value here is negative 3. So negative 3, the opposite of that is 3, squared is 9, fill it in, all over 2 times the a value, which is 1. So if we were to do this out, what we'd get is what they have there, listed there, which would be, they got 2 numbers listed in the middle of page 206. They have 25.106, and they have negative 22.106. Okay, so now we've got to step out of our math world and ask ourselves, does this make sense? Can you have a 25-inch pizza? Yes. Can you have a negative 22-inch pizza? This doesn't make sense. You can't have this. So we're gone. You've got to take the answers you get and ask yourself, does this make sense? Is it reasonable? Can you have a negative distance? You cannot. So that doesn't work. So D, we've already done. E, use the discriminant to show that there are no diameters for which the price is 0. So we want to show that we're going to use the discriminant here. Let me get rid of all this. So the discriminant, which is b squared 9 minus 4 times a times c. So I'm going to get 9 minus 180, so which is negative 171. There's my discriminant. Now what does a negative discriminant tell me? Well, if I was looking at the quadratic equation, it would be the opposite of b, plus or minus the square root of negative 171 all over 2a. I don't have to worry about these at all. I just want to look here. Can you take the square root of a negative number and get out a real number? You cannot. So if you cannot get a real number out, that means there are no diameters for which the price could be 0. Period. None. So there are no diameters for which the price could be 0. Pretty simple. And if they want us to show that a linear function does not fit the original data. Okay, to show that a line doesn't fit the data, all you have to do is, you'll see there in, I'll go ahead and show you. So we have 3 points. We've been given 3 points. 8, 85, 10, 115, and 13, 175. So if we had a line, okay, so this would be, the slope of this here would be these 2 points, would be the change in y. So let's say 115 minus 85 is 30, yeah. So we get 30 over the change 3, which the slope would be 10 between those 2 points. Now let's do the slope between these 2 points. The slope between these 2 points is 60 over 3. The slope there is 20. A line has to have the same slope everywhere. So because the slope between these 2 points is 10 and the slope between these 2 points is 20, it cannot be a line. And the last letter for this is find the vertex and use it in other points that are given or that have been calculated to sketch the graph. So how do we find the vertex of this? Well, like in past sections, to find the vertex, we have to complete the square. So y minus 45, because the first step is to kick out this constant, y minus 45 equals x squared minus 3x. My coefficient of x is 1, so that makes life easy. I'm going to take half of this and square it. So half of this is negative 3/2. So when I square it, I get 9/4. I'm going to add that to both sides. Okay, so I have y, this is 45 be 180/4. So I can add them together. So I get minus 171 over 4 equals y minus 3/2 squared. Let me just make sure I'm getting this, yeah. Oh, you know what? It would be easier here. Once we get to this point, we have x minus 3/2 squared, right? So we know that, we know here that, oh, that was actually pretty fast, because 4 into that is 4. Yeah, that's right. So we're done. We found the vertex. And because we're now on y minus k equals x minus h squared, and my a here is 1. So my vertex, it would be 3/2, 171 over 4. That's my vertex. But you can also do it by quickly, remember the x value of the vertex, h equals, it's the same thing as the opposite of b over 2a. Because that's what this ends up being, right here. Is the negative 3/2 is the opposite of b, which is negative 3, over 2 times a, which is 2. So you can find h and then substitute in to find y if you want. Either way. And then you would want to plot the points that we have. We have these 3 points, and we've got this point. We should easily be able to, and plus the point for the 20-inch pizza and the 25.1-inch pizza. So you should be able to find those pretty easily. On to example 2. Example 2. A rectangular pond 5 meters by 7 meters is to be surrounded by a walkway of width x meters. This problem concerns a rectangular region taken up by the pond and the walkway. So we know that this distance here is 5, and this distance here is 7, and we want a walkway around the whole thing. Now, so that's what we know so far. I like to draw pictures. They have their picture there. They're telling you the width of this walkway all the way across, all the way around is going to be x. All right, so in A, write the length and width of the region as a function of x. Okay, so the length of this pond, if we go this way as length, okay, would be 7 plus 2x. Because we have this 7 here, and x here, and x here. So it would be x, 7 more, and x more would be 7 plus 2x. And the width would be 5 plus 2x. Because we would start here, we'd go x steps or units, we'd go 5 more, and then we'd go x more. So we'd get 5 plus 2x. That's how we would describe x. Or, yeah, and the length and the width. We want to write the area of this region as a function of x. Well, area of a rectangle is length times width, right? So this means that my area, y, would be 7 plus 2x times 5 plus 2x. And now I've written it as a function of this, and we could go ahead and square it out. We would get, I'm going to do some of these parts in my head just real fast. 4x squared plus 10x plus 14 plus 24x plus 35. Is that right? Yeah. Okay, so now we know it's quadratic. It's in our normal form. Y equals ax squared plus bx plus c. Now C, predict the area of the region if x is 1, 2, or 3. So if I put 1 in for, so what they're asking now, what happens when x is 1? I put the 1 in. Y equals 4 plus 24 plus 35. 28 plus 35 is 63. So you can see all I've done is shove in the numbers. If I put a 2 in, I would get 4 times 4 plus 48 plus 35, 99. And if I put the 3 in, I would get 4 times 9 plus 24 times 3 plus 35, which would be 143. So once you have an equation, you can just substitute in the x values to find the y's. Okay, the next step. Find the value of x, which makes the region have an area of 150 square meters. So remember, our area is represented by length times width. So y is my area. So I'll say that y equals the area. Okay, so they want an area to be 150 square meters. So that means my y is going to be 150. And so now what do we have? We have to solve this equation. This is one equation with one thing we don't know. We don't know x. Since it's one equation with one thing we don't know, we can solve it. So remember, how we would solve this is how we'd solve everything else. We want to set it equal to 0 first. So 0 equals 4x squared plus 24x. Bring this as a negative 150 over, so you get minus 115. Now, I have a quadratic equation. I don't want to factor that in my head. I will just use the quadratic formula to get that answer. And that's exactly what they do. At the bottom of page 208, you can clearly see, bottom of in letter D, you can clearly see that that's exactly what they're doing. They're using the quadratic formula to get the answer. Letter E would be sketch the graph in a reasonable domain. So sketching the graph is simply putting the points there and making the line that would connect them, or the curve that would connect them. Now they use the word reasonable domain. What does that mean? Well, could the walkway be 0? Yeah, you could have a walkway of nothing. They could decide not to put that walkway in. Could the walkway be -5? Well, that doesn't make any sense because you can't have a negative distance. So in this situation, when you graph it, you don't want to graph any values where x, which represents, which is affecting the length of the walkway or the width of the walkway, this width of the walkway can't be negative. Since it can't be negative, you can never have x values that are negative. So remember, in the quadrants, x is negative back here. So the graph won't exist there at all. And you also can't have negative areas. So if y represents my area, we're talking about real things like ponds and walkways, I can't have negative area. So this is the only quadrant that I can graph in. And that's why their picture only shows that quadrant. So the rest of the problems here are very much like this. They are wanting you to use the quadratic equation, use the quadratic formula when you need to find a root or a solution, and you just work your way one at a time through it. Now, if you're having trouble, I suggest watching these problems and trying to work them and watch the problem, work it. You will get it the more you practice it. And since you have a video showing how to work it, I would use the video if you're struggling. Good luck.